Okay, so we've got another problem here where we have to do, we have to complete the square first before we're able to use trig substitution. So we grab the 6 and we divide by 2, which is 3. Square it, we get 9. And so then we add 9 and then we subtract 9, which means that we're going to end up with a, well, let me do plus 6 and then minus 9. So the plus 6 is this one, and then the minus 9 is because I added this 9 over here. So this is equal to x plus 3 squared and then minus 3. Okay, so then you do, you substitute, you let u be x plus 3, and then du is going to equal to just dx. So here we have du, and then this is going to equal to u squared minus 3, and then the whole thing is, in this case, squared. So this inside is this right here. Okay, so let me separate that. Okay, so then what I have is the integral of du over u squared minus 3 squared. Okay, so then in this case, u would equal to the square root of 3 secant theta, and then du would equal to square root of 3 secant theta tangent theta. Okay, so, d theta. All right, and so then we move into swapping the u squared minus 3 squared, and so this is equal to 3 secant squared theta minus 3 squared, which is equal to 9, and then secant squared theta minus 1, because you take out the 3 and then you square it. And so, and squared, sorry. So this is equal to 9 secant squared minus 1, that's tangent squared. So this is going to be tangent to the 4th theta. So right here, this one's going to be swapped out with a 9 tangent to the 4th. And then du is this one right here. So then what I get is the integral of square root of 3 secant theta tangent theta d theta over 9 tangent to the 4th theta. Okay, so then I have, let's do some simplifications here. This is going to equal to square root of 3 over 9, the integral of secant theta over tangent cubed theta d theta. Okay, and so let's, to do this, why don't we, there's no immediate substitution that we can do or anything like that. So why don't we turn it into sines and cosines. So this would mean that, so secant's 1 over cosine, tangent is sine over cosine. So then that means I would get cosine squared theta over sine cubed theta. Okay. Now, let's see here. Any ideas on what to do? It's not completely obvious, but you have cosines on top, sines on the bottom. But your best bet is probably going to be to use some trig identities. So how about if we switch this cosine squared for a 1 minus sine squared? Then you would have 1 over sine cubed theta d theta, and then minus root 3 over 9, the integral of sine squared theta over sine cubed theta d theta. Okay, so then I think I need more room. Okay, so then this is equal to square root of 3 over 9. The integral, 1 over sine cubed. Well, that's just cosecant cubed theta, d theta. And then minus root 3 over 9. This is equal to 1 over sine theta, or cosecant theta. So this is cosecant theta, d theta. Okay, so let's use the reduction formula here for cosecant raised to a power. So this is going to equal to root 3 over 9 times negative cotangent theta cosecant theta over 2 plus 1/2 the integral of cosecant theta d theta. Okay, and then minus, let's just factor out the root 3 over 9, and I'm just going to do minus the integral of cosecant theta d theta. Now there's a reason why I didn't evaluate this one, even though I could. Notice that these two are the same integral, right? So if you combine these two together, this is simply negative 1/2 times the integral of cosecant theta d theta. Okay, so then what I get is the square root of 3 over 9 times negative cotangent theta cosecant theta over 2, and then minus 1/2, and then the integral of cosecant is the natural log of the absolute value of cosecant theta minus cotangent theta. Okay. Plus C. All right, so now we need to just go back to the original variable. So to do that, let's do a little bubble here. All my other stuff is gone at this point. But I had that secant theta is going to be u over square root of 3. So let me make a little right triangle here to show that. So I've got theta. Then that means that this side is going to be u. Ooh, that's a terrible color. This side's going to be u. This one's going to be square root of 3. And so then I have the square root of u squared minus 3 for that side. Okay, so then what I'm going to get is this is, okay, let me do a little bit more simplification. Why don't I, since there's a 2 on each one of these, let's take that out and let's write that as root 3 over 18. And then I have minus cotangent of theta. That's going to be root 3 over the square root of u squared minus 3. Okay, and then times cosecant theta. That's going to be u over the square root of u squared minus 3. Okay, and then minus, I don't know if this is going to fit, natural log of the absolute value. It's going to be close. Maybe I'll just erase this a little bit. Okay, just give me a second here to make a little room. Okay, and then natural log of cosecant, so that again u over the square root of u squared minus 3 minus cotangent, which is root 3 over the square root of u squared minus 3. And then also remember that u is equal to x plus 3. So each one of these would be x plus 3's. And I'll let you write it all over again, but replacing those with x plus 3's. And then don't forget plus some constant c. And that's it.